6. Geomorphic process. Why is the surface of the Earth uneven? The Earth's crust is dynamic. It has moved and moves vertically and horizontally. Of course, it moved a bit faster in the past than the rate at which it is moving now. The differences in the internal forces operating from within the Earth, which built up the crust, have been responsible for the variations in the outer surface of the crust. The Earth's surface is being continuously subjected to external forces induced basically by energy, sunlight. Of course, the internal forces are still active, though with different intensities. The external forces are known as exogenic forces and the internal forces are known as endogenic forces. The actions of exogenic forces result in wearing down, degradation, of relief, elevations and filling up, a gradation, of basins/depressions, on the Earth's surface. The phenomenon of wearing down of relief variations of the surface of the Earth through erosion is known as gradation. The endogenic forces continuously elevate or build up parts of the Earth's surface and hence the exogenic processes fail to even out the relief variations of the surface of the Earth. So, variations remain as long as the opposing actions of exogenic and endogenic forces continue. Geomorphic processes. The endogenic and exogenic forces causing physical stresses and chemical actions on Earth materials and bringing about changes in the configuration of the surface of the Earth are known as geomorphic processes. Diastrophism and volcanism are endogenic geomorphic processes. Weathering, mass wasting, erosion and deposition are exogenic geomorphic processes. What are geomorphic agents? Any exogenic element of nature, like water, ice, wind, etc., capable of acquiring and transporting earth materials can be called a geomorphic agent. When these elements of nature become mobile due to gradients, they remove the materials and transport them over slopes and deposit them at lower level. A process is a force applied on earth materials affecting the same. An agent is a mobile medium, like running water, moving ice masses, wind, waves and currents etc., which removes, transports and deposits earth materials. Running water, groundwater, glaciers, wind, waves and currents, etc., can be called geomorphic agents. Endogenic processes. The energy emanating from within the Earth is the main force behind endogenic geomorphic processes. This energy is mostly generated by radioactivity, rotational and tidal friction and primordial heat from the origin of the Earth. This energy due to geothermal gradients and heat flow from within induces diastrophism and volcanism in the lithosphere. Due to variations in geothermal gradients and heat flow from within, crustal thickness and strength, the action of endogenic forces are not uniform and hence the tectonically controlled original crustal surface is uneven. Diastrophism. All processes that move, elevate or build up portions of the Earth's crust come under diastrophism. They include orogenic processes involving mountain building through severe folding and affecting long and narrow belts of the Earth's crust. Erogenc processes involving uplift or warping of large parts of the Earth's crust. Earthquakes involving local relatively minor movements. Plate tectonics involving horizontal movements of crustal plates. In the process of orogeny, the crust is severely deformed into folds. Due to epeirogeny, there may be simple deformation. Orogeny is a mountain building process, whereas eperogeny is continental building process. Through the processes of orogeny, epeirogeny, earthquakes and plate tectonics, there can be faulting and fracturing of the crust. All these processes cause pressure, volume and temperature, private changes which in turn induce metamorphism of rocks. Volcanism. Volcanism includes the movement of molten rock, magma, onto or toward the Earth's surface, and also formation of many intrusive and extrusive volcanic forms. Exogenic processes. The exogenic processes derive their energy from atmosphere determined by the ultimate energy from the sun and also the gradients created by tectonic factors. Why do you think that the slopes or gradients are created by tectonic factors? Gravitational force acts upon all Earth materials having a sloping surface and tend to produce movement of matter in downslope direction. Force applied per unit area is called stress. Stress is produced in a solid by pushing or pulling. This induces deformation. Forces acting along the faces of Earth materials are shear stresses, separating forces. It is this stress that breaks rocks and other Earth materials. The shear stresses result in angular displacement or slippage. Besides the gravitational stress, Earth materials become subjected to molecular stresses that may be caused by a number of factors, amongst which temperature changes, crystallization, and melting are the most common. Chemical processes normally lead to loosening of bonds between grains, dissolving of soluble minerals, or cementing materials. Thus, the basic reason that leads to weathering, mass movements, and erosion is development of stresses in the body of the Earth materials. As there are different climatic regions on the Earth's surface, the exogenic geomorphic processes vary from region to region. Temperature and precipitation are the two important climatic elements that control various processes. Exogenic geomorphic processes. Weathering. Weathering is defined as mechanical disintegration and chemical decomposition of rocks through the actions of various elements of weather and climate. Weathering is action of elements of weather and climate over Earth materials. There are a number of processes within weathering which act either individually or together to affect the Earth materials in order to reduce them to fragmental state. There are three major groups of weathering processes. Chemical weathering processes, physical or mechanical weathering processes, biological weathering processes, chemical weathering processes. A group of weathering processes viz. Solution, carbonation, hydration, oxidation and reduction act on the rocks to decompose, dissolve or reduce them to a fine clastic state through chemical reactions. Water and air, oxygen and carbon dioxide, along with heat must be present to speed up all chemical reactions. Solution. When something is dissolved in water or acids, the water or acid with dissolved contents is called solution. On coming in contact with water, many solids disintegrate and mix up as suspension in water. Soluble rock-forming minerals like nitrates, sulfates, and potassium etc. are affected by this process. So, these minerals are easily leached out without leaving any residue in rainy climates and accumulate in dry regions. Minerals like calcium carbonate and calcium magnesium bicarbonate present in limestones are soluble in water containing carbonic acid, formed with the addition of carbon dioxide in water, and are carried away in water as solution. Carbon dioxide produced by decaying organic matter along with soil water greatly aids in this reaction. Carbonation. Carbonation is the reaction of carbonate and bicarbonate with minerals and is a common process helping the breaking down of feldspar and carbonate minerals. Carbon dioxide from the atmosphere and soil air is absorbed by water to form carbonic acid that acts as a weak acid. Calcium carbonates and magnesium carbonates are dissolved in carbonic acid and are removed in a solution without leaving any residue, resulting in cave formation. Hydration. Hydration is the chemical addition of water. Minerals take up water and expand. This expansion causes an increase in the volume of the material itself or rock. Calcium sulfate takes in water and turns to gypsum, which is more unstable than calcium sulfate. This process is reversible and long. Continued repetition of this process causes fatigue in the rocks and may lead to their disintegration. Salts in pore spaces undergo rapid and repeated hydration and help in rock fracturing. The volume changes in minerals due to hydration will also help in physical weathering through exfoliation and granular disintegration. Oxidation and reduction. In weathering, oxidation means a combination of a mineral with oxygen to form oxides or hydroxides. Oxidation occurs where there is ready access to the atmosphere and oxygenated waters. The minerals most commonly involved in this process are iron, manganese, sulfur, etc. In the process of oxidation, rock breakdown occurs due to the disturbance caused by addition of oxygen. Red color of iron upon oxidation turns to brown or yellow. When oxidized minerals are placed in an environment where oxygen is absent, reduction takes place. Such conditions exist usually below the water table, in areas of stagnant water and waterlogged ground. Red color of iron upon reduction turns to greenish or bluish gray. Physical weathering processes. Physical or mechanical weathering processes depend on some applied forces. The applied forces could be I. Gravitational forces such as overburden pressure, load and shearing stress. 2. Expansion forces due to temperature changes, crystal growth or animal activity. 3. Water pressures controlled by wetting and drying cycles. Most of the physical weathering processes are caused by thermal expansion and pressure release. These processes are small and slow but can cause great damage to the rocks because of continued fatigue. The rocks suffer due to repetition of contraction and expansion. Unloading and expansion. Removal of overlying rock load because of continued erosion causes vertical pressure release, with the result that the upper layers of the rock expand, producing disintegration of rock masses. Fractures will develop roughly parallel to the ground surface. In areas of curved ground surface, arched fractures tend to produce massive sheets or exfoliation slabs of rock. Exfoliation. Large, smooth rounded domes called exfoliation domes result due to this process. Temperature changes and expansion. Various minerals in rocks possess their own limits of expansion and contraction. With rise in temperature, every mineral expands and pushes against its neighbor, and as temperature falls, a corresponding contraction takes place. Because of diurnal changes in the temperatures, This internal movement among the mineral grains of the superficial layers of rocks takes place regularly. This process is most effective in dry climates and high elevations where diurnal temperature changes are drastic. The surface layers of the rocks tend to expand more than the rock at depth, and this leads to the formation of stress within the rock, resulting in heaving and fracturing parallel to the surface. Due to differential heating and resulting expansion and contraction of surface layers, and their subsequent exfoliation from the surface results in smooth rounded surfaces in rocks. In rocks like granites, smooth-surfaced and rounded small to big boulders called tors form due to such exfoliation. Freezing, thawing, and frost wedging. Frost weathering occurs due to growth of ice within pores and cracks of rocks during repeated cycles of freezing and melting. This process is most effective at high elevations in mid-latitudes where freezing and melting is often repeated. Glacial areas are subject to frost wedging daily. In this process, the rate of freezing is important. Rapid freezing of water causes its sudden expansion and high pressure. The resulting expansion affects joints, cracks, and small intergranular fractures to become wider and wider till the rock breaks apart. Salt weathering. Salts in rocks expand due to thermal action, hydration, and crystallization. Many salts like calcium, sodium, magnesium, potassium, and barium have a tendency to expand. Expansion of these salts depends on temperature and their thermal properties. High temperature ranges between 30 and 50 of surface temperatures in deserts favor such salt expansion. Salt crystals in near-surface pores cause splitting of individual grains within rocks, which eventually fall off. This process of falling off of individual grains may result in granular disintegration or granular foliation. Salt crystallization is most effective of all salt weathering processes. In areas with alternating wetting and drying conditions, salt crystal growth is favored and the neighboring grains are pushed aside. Sodium chloride and gypsum crystals in desert areas heave up overlying layers of materials, and with the result polygonal cracks develop all over the heaved surface. With salt crystal growth, chalk breaks down most readily, followed by limestone, sandstone, shale, gneiss and granite, etc. Biological activity and weathering. Biological weathering is contribution to or removal of minerals and ions from the weathering environment and physical changes due to growth or movement of organisms. Burrowing and wedging by organisms like earthworms, termites, rodents, etc. help in exposing the new surfaces to chemical attack and assists in the penetration of moisture and air. Human beings, by disturbing vegetation, plowing and cultivating soils, also help in mixing and creating new contacts between air, water and minerals in the earth materials. Decaying plant and animal matter help in the production of humic, carbonic and other acids which enhance decay and solubility of some elements. Plant roots exert a tremendous pressure on the earth materials, mechanically breaking them apart. Significance of weathering. Weathering processes are responsible for breaking down the rocks into smaller fragments and preparing the way for formation of not only regolith and soils, but also erosion and mass movements. Biomes and biodiversity is basically a result of forests, vegetation, and forests depend upon the depth of weathering mantles. Erosion cannot be significant if the rocks are not weathered. That means, Weathering aids mass wasting, erosion and reduction of relief, and changes in landforms are a consequence of erosion. Weathering of rocks and deposits helps in the enrichment and concentrations of certain valuable ores of iron, manganese, aluminium, copper, etc., which are of great importance for the national economy. Weathering is an important process in the formation of soils.